This is the CadMakers mass timber design for fabrication template, part 1 of a 4-part series of our mass timber design to execution solutions series. First, we define the number of grids and spacing between them, and then use the model parameters to define the elevations and number of floors. This master grid will be reused and referenced by components and members throughout the project. Opening up the sketcher, we can define the members we'd like to incorporate to the design. Our team has defined a custom nomenclature based on simple geometric inputs, with an associated name for each member which will be used from a database catalog. On the ground floor, we'll define 2 walls and then add an intersecting point to define the vertical joint between them. In addition, we'll place isolated points for columns. Note how all of the simple geometry has been dimensioned or constrained to the grid lines. Exiting the sketch, we can run the update tool, which will apply the details of each catalog member in the form of a UDF in the context of the floor plan. After the initial instantiation, each UDF member can be further modified via offset, rotation, or even a change in profile. In this example, we modified the original butt joint detail to a corner lap joint detail, and modified the wall thickness based on a catalog member spec provided by the CLT manufacturer, enabling design for manufacturing and assembly methodologies. This logic applies to all mass timber elements with the flexibility to create your own library and catalogs. Moving up the slab level, we can create another sketch defining the slab edge outline, constraining the grid, and then adding joint locations to intersect the slab profile. Within each subdivision, we will also add a line to define the grain direction of each panel individually. Lastly, on the same floor sketch, we'll create lines to define the beams at level 2, naming them accordingly. Exiting the sketch and applying the UDFs, we once again will instantiate the elements with joint details applied immediately. At any point in the design, we can return to any one of the reference sketches to add or remove wireframe inputs, removing it or adding it from the design. Similar to the vertical wall joint, we can select any of the joint profiles from the drop-down menu to change the detail. The tool will automatically recognize any interfacing elements that the change impacts and update accordingly as well. Using one floor sketch as a template, we can copy and paste it at the level 2 elevation and then rerun the UDFs to instantiate the geometry. Not only does this tool support orthogonal geometries, but we can also incorporate slope geometries parametrically as well. Here we'll create a new plane angled at 10 degrees to horizontal, and then swap the planes that the sketch is referencing to propagate the changes to the members. When this is completed, the column heights and the angles have automatically adjusted. However, the projected grid lines have shifted and will need to be replaced. Going into the sketch, we can reconstrain those elements to supporting planes to have everything aligned once again. The beams have also been overextended due to the inclined planes, so we can create a boolean remove operation to trim those specific selected elements. Once we have completed our initial design massing, we will push each UDF feature into its own bill of material part. While this action is running, each of the single piece shop drawings is being generated uniquely and individually for each member. The 2D drawing contains a link to the 3D member, such that as the geometry is updated in the 3D, the changes will be reflected in the 2D drawing. Here's the initial design with the wood grain material visualized. Next, we'll add the steel connection details to finalize the structural design. We have a catalog of pre-engineered recons and custom design connections. Embedded in each of these connections is also the remove volume shown in red that will be used in a boolean remove operation for interfacing mass timber elements. After inserting each of the catalog components into the model view, we'll constrain them to an associated axis and then use an assembly pattern to pattern the reference connection on the other desired axis locations. The final step is to remove the machining operations required for the steel connections from the mass timber. We conduct this by using a tool that first checks for the clash of the remove volumes against the mass timber elements and selectively machines the cutouts. After removal, there is no overlap in the timber or the steel connections. In addition to the embeds, the grooves for the recon have also been removed. Each timber part is ready to be exported to BTLx, which we will show in part 2 of this mass timber video series, or step format. With these individual part data files, we can start to nest to reduce material waste as well. This is a process we'll show in part 3 of our mass timber series. Lastly, since we have the full fabrication model and bill of materials, we can also leverage the model to be used for parts and material tracking for project delivery and client sign-off. It is important to note that the model throughout every stage still remains fully parametric, such that we could change the grid lines or go back and modify or replace a connection. When we modify a connection, it will propagate that reference to all previously specified locations. This has been a CadMakers production. Thanks for watching. If you like this video, please comment, like, and subscribe, and we'll see you in the next video.